Ano? And i-detail na po in every step. So for the first step, okay, recall sa na po. Tara, assign. First step, assign. Muna ang keyword sa first step. Assign current, okay, in every resistor. Okay, or tawag ko na to load. Okay, so assign current in every resistor or in every load in the future na igabot to sa AC circuits, maabot na gitag not resistor only but inductor, capacitor. So muna nga giapila na lang na term load. Okay, in every resistor, you're going to assign a current. Now, of course, ang current, there should always be a direction for the current. So it's up to you na whether you're going to assign the direction going left, going right, going up, going down. It's up to you na, no? Bahala na, asa na padong. It doesn't matter. As long as you can assign current in every resistor. And also, for the name of the current, it's up to you sa gihapon. Okay, as long as you can assign current. Let's say, current IA, current IB, current I1, current I2. Okay, so ina na lang. Ay kabalak ka og masayop ka og assume. Okay, so dini pareha sa imuhang pag-assume sa una nga nasakitan ka. This one, dili ka masakitan, ay kabala ka. Okay, so assume as much as possible. Dili na ka masakitan. Okay, what na I take note, no? Take note. Okay, that the number of unknown currents, number of unknown currents equals number of equations needed. Okay. So kung pila ka buok unknown current ang imuhang nabutang diha sa circuit, that will also be the number of equations you need. For example, there are 3 unknown currents. Let's say, for example, you have current IA, IB, and IC. Therefore, you need 3 equations to solve those unknown currents IA, IB, and IC. Okay? So meaning, the greater number of unknown currents, okay, in your circuit, the greater number of equations needed. And you already know that that is not a good sign. That is not that is not a very nice scenario. Nga daghan kay kag equations, let's say 5 equations, 5 unknowns, 6 equations, 6 unknowns. Samot matagbaw na ganitas 3 equations, 3 unknowns, unsa na lang kahag moabot nag 6 equations, 6 unknowns. Okay? So much better gyud nga mas gamay lang ang unknown nga current. Dili na lang ta mag-assign, sir. Okay? Hindi man sa na pwede. Okay? You must assign current in every resistor. Okay? Kay naay usa nga dili nimo ma-assignan, except lang siguro sa circuit nga there is already a current given. Okay? So there are circuits nga i-given na daan pilay current diha nga resistor. Okay? So nana. Pero katong mga wa gyud, so the more unknown currents present in the circuit, the more equations you need. That is step number 1. Now, let's proceed to step number 2. Okay? For step number 2, assign lang gihapon. So, ang keyword for step number 2, same for step number 1. Assign, but this time, assign loop in every closed circuit, okay, where there are no current sources. Okay, current sources. So, kung number 1, assign current ka, sa number 2, assign loop ka. Of course, when you assign a loop, it should be a closed circuit. So, ang mag-loop ka sa open circuit, walay loop mapurma na. You cannot form a loop in an open circuit. Okay, you can only form a loop if that is a closed circuit. Okay, but take note that you assign this loop in a closed circuit where there are no current sources. Why? Okay, why? Don't worry, I will explain that in the moment that I will give an example and apply the steps to the example. It's much easier to explain this scenario in number 2 during the example. Okay? And also, sir, naada ito current source? Yes, not just a voltage source, but we also have a current source. Okay? So, if you don't know what are the different types of sources, let me explain first the different type of sources. Okay? So, I believe some of you here are not aware. So, types of sources. Let me explain this one. Okay? Since I've already introduced the current source in step number 2, let me explain first the different types of sources. Okay? First type of source you have the independent. Okay? First type, sige, first type of source is called the independent. Okay? Independent voltage source. Okay, independent voltage source. So, yahang symbol would be like this. Independent meaning it has its own value. Let's say, for example, 10 volts. For example, it has its own value, independent. So, wa siya nagsalig sa ubang mga sources. Then, of course, if you have an independent voltage source, okay, of course, you will also have an independent current source. Okay, so symbol for an independent current source, we will have this one. Ay, this should be a, dili na letter P ha. This should be an arrow. Why arrow? Because again, current always has direction. Diba? Mag-flow biya ng current. So, na siya klaro nga direction. That's why it's represented by an arrow. Okay? So, this independent current source meaning it has its own value. Let's say, for example, this is 2 amperes, for example. Okay? Of course, if there is an independent source, of course, there's also a dependent source. Okay, so you have dependent voltage source. Okay, dependent voltage source, of course. Okay, plus minus gyapon kay voltage source man ka, but it's not circle anymore, but this time diamond na. Okay, so this will be plus minus. So, dependent man siya, meaning it's dependent on other areas. Let's say, for example, ang value ani is, let's say, 3V1, for example. So, meaning this voltage source is dependent on the value of V1. Whatever is the value of V1, multiply it by 3, that would be the value of this dependent voltage source. Okay? So, muna pasabot na. But of course, kung na ay dependent voltage source, there's also a dependent current source. Okay? Kompleto ko na gina. Okay, dependent current source. Same gihapon, its equivalent diagram is arrow gihapon, but this time same na po diri no. Diamond na agporma. Okay, so you have here na. Okay, so again, dependent man siya. Dependent man siya, so meaning it doesn't have its own value. So let's say for example, it's called this 0.5 I A, for example. So meaning this current is dependent on the current IA. So whatever is the value of IA, multiply it by 0.5, that would be the value of this current source. Okay? But also, there are also types. Okay, there are also different types of dependent sources. Okay, the types of dependent source. So there are also different types of dependent source. Sources na lang. Okay? So, ito man na siya mga klase-klase sa dependent source. You will have first, okay? Let's call it a voltage, okay? Voltage controlled voltage source. So this is the first type of dependent source. Meaning you have a voltage, meaning you have a dependent na voltage source, but it is controlled by, you have a dependent voltage source, but it's also dependent upon another voltage source. So just like this one, no? So for example, kana 3V1, it's a voltage source that is dependent upon another voltage source. Okay? Then you also have, kung naaday kay voltage source nga dependent sa another voltage source, naabasad sir nga voltage source nga dependent sa current source? Answer is yes. So of course, that is current controlled, okay? Current controlled voltage source. Of course, naasa na, no? So same gyapon, you will have the same symbol. Okay, voltage source na siya. Pero dependent siya sa current, let's say, 4ix, for example. Yan na, no? Okay, so magdepende yung value sa other source, but this time not just a voltage source, but a current source. Okay, then you have, siyempre, kung naa kay variety sa voltage source, naapog kay variety sa current source. So of course, you also have current controlled, okay, current controlled current source. Okay, so same gapon, you will have a current dependent current source. Same rane. So it's it's dependent upon another current source. But just like with a voltage source, you also have a voltage controlled, okay? You also have a voltage controlled current source. Okay, so with this one, you have a current source, dependent current source, but it depends, the value is dependent on another voltage source. So that would be, let's say, for example, let's say this will be 10, yun ang 10, sige lang 10, 25 Vx, for example. Okay, so whatever is the value of Vx, multiply it by 25, that would be, that would be the value of this current source. Okay, so these are the different types of sources, the independent source and the dependent source, and then the different types of dependent sources. So going back from this, step number 2, okay, you have to assign the loop in a closed circuit, okay, in every closed circuit where there are no current sources. So make sure nga walay current source diha nga closed circuit. So I've already explained what is a closed circuit. Nani, no? Closed circuit na, or this can also be a closed circuit. Okay? So, make sure nga wala ni. Or, pwede sad ang dependent source. Basta kay current source na siya. Okay? So, you assign a loop, basta walay current source diya. Whether it's independent or dependent. Okay? Now, why? Okay? This step number 2 is related to step number 3. For step number 3, okay, pag gumani mo assign, by the way, no, for your loop, it's up to you if you're going to assign clockwise or counterclockwise rotation. It's up to you. Again, just like with step number 1, you can assign, okay, you can assume the directions, you can assume the rotations. Don't worry, dili lagi ka masakitan na. Okay, it will not affect the final answer of the circuit or of the problem. Okay, so let's proceed with step number 3. For step number 3, you're now going to apply. Okay, you're now going to apply KVL on the assigned loops. Okay. You're now going to apply KVL on the assigned loops. Now, this is the reason, okay, why ang step number 3 mo oy reason nga nung sa step number 2, dili ka mag-assign og loop sa naay current source. Why? It's because you're going to apply KVL. Take note, KVL, meaning Kirchhoffs voltage law, it will only involve voltage. Now, kung naay current source ang imuhang loop, okay? Ang location sa loop, there is a current source. What voltage are you going to determine sa current source? Technically, wala may voltage diha sa imong current source. Sample kanino? 2 amperes. Inig-apply ni mo KVL diha. Wala man kay voltage diha. Okay? So, in that moment na wala kay voltage, na kailangan man yun nga na ay voltage kaya nag-apply man kag KVL. So not necessarily nga dili pwede, but mas maka-complicate because mapugos ka. For example, nag-apply mo og KVL dire nya wala may voltage, you cannot use 2 amperes because that is not voltage. Sige, mapugos na lang ka, mag-assume na lang ko. So mag-assume ko nga kani nga current source na siya voltage nga VA, for example. Okay? Now, what is the disadvantage of this one? The disadvantage of this one is this is another unknown variable. With an additional unknown variable, again, you have to add more equation. Kaya di man pwede nga, you have 3 unknowns but you only have 2 equations. You cannot solve that. Okay? So if you have 3 unknowns, you should have 3 equations. For this one, napunan og isa ka unknown. So dapat magpuno na sa gaglain nga equation. What if ay mo 3 unknowns, 3 equations, nagliso na gay ka na, mapunan og isa, mahimo ng 4 unknowns, 4 equations. Samot ka maglisod. Okay? So that's the reason behind it. Okay? Technically, dili man gid siya kanang dili gid siya pwede, pero para lang malihayan ang kalisod or so that you won't have a very complicated solution, okay? Lihayin na lang gid ni siyang mag-loop ka sa naay current source. So as much as possible, do not assign loop in a circuit in a closed circuit where there is no current source, so that when you apply step number 3, applying KVL on that assigned loop, you won't have that problem na. Okay? But take note how to apply KVL. So recall ta rules. Okay? So these are the rules in applying KVL. So take note, for example, if this is my resistor, okay? Let's say resistor R. Nya, this is the current gi-assign sa kanang resistor, let's say current IA. And, di ba, kung naamang ginay loop, di ba, on the assigned loop. So for example, this is my loop. Let's say this is loop A. Okay, loop A. Now, if the loop and the current direction is the same, then the voltage on this resistance is equal to negative. Okay, so how to determine the voltage of the resistor? If there is current and there is resistance, recall from Ohm's law, V is equal to I times R. So therefore, V ani, ang voltage ani nga resistor, if the direction of the loop and the current is the same, then the voltage on the resistor will be negative. Negative IA times R. Okay, so let's call this rule 3.1. Okay, the next rule 3.2. Same. You have a resistor R, but the direction of the current is on the other side. Let's call this current IB. Okay? Then let's have this loop. Let's say, loop B lang. Lainon lang na ako ang loop, no? Okay? Now, if the loop and the current direction is opposite, okay? Opposing ang ilang direction, then the voltage on this resistor is positive. So this will be positive IB times R. Okay? Now, except for the resistor, we also have a voltage source. So naamang yun na voltage source ang atuang circuit. It's not just limited to the resistor. So there's also rule for a KVL on a voltage source. So rule 3.3. For example, this is my voltage source. Okay? Let's say VA. And this will be my loop. Let's say loop C. Okay? Now, if this is the scenario, your voltage will be, the voltage that you're going to get, you can get from this voltage source will be negative. Nga naman. So let's you look at it this way. The loop, it's a loop C, has entered the positive side of the voltage source and exits at the negative side of the voltage source. So nisod sa positive side, nigawa sa negative side. Asa siya dapit nga part ni exit, that will be your sign. That will be your follow-up sign. So the exit siya sa negative side, therefore ang voltage ani will become negative VA when you apply KVL. And also, rule 3.4, let's say another voltage source. Okay. Then let's call this VB. Okay? Pero opposite ang loop, let's say loop D. Okay? So with this one, the loop enters the negative side and exits the positive side. So as I've said before, you will follow the exit side. The exit side is positive, therefore the voltage for this one, when you apply KVL, will become positive VB. Okay? So these are the rules when you apply KVL. Okay? So ito ning klarohon, ginpaglantir ba kayo ni, no? Mura ba ni magdag bida, inig apply ni mo Kirchhoffs Law. Okay, so these are the rules when you apply KVL on the assigned loops. Okay? Now, take note nga sa assigned loops na ka mag-KVL. But we have a certain number of equations that we need. What if, for example, we only have 2 loops? Okay? So, from the 2 loops, nag-apply tawag KVL. So, therefore, we have formed 2 equations from the 2 loops. What if we need 3 equations? Okay, there are 3 unknown currents, IA, IB, and IC, for example. Okay? Di na ito masolve, sir. Kay 2 equations na niya, 3 unknowns. Now, for that problem, of course, na anay remedy, we will proceed with rule. We will proceed with step number 4. Okay? On step number 4, if you cannot achieve the desired number of equations from step number 3 using KVL, then of course, we'll go forward ka step number 4. Kung wala ka ka-achieve sa desired number of equations sa KVL, then you will use KCL. Of course, recall that Kirchhoffs Law has 2 laws, KVL and KCL. KVL pa lang atong nagamit. So, we will use KCL. So, this time, apply KCL to any node, okay, where there is, okay, no connected voltage source. Okay, now what is with this scenario? Of course, this scenario for step number 4 is just the same as the reason for step number 3. Okay? Mag-apply man ka og KVL sa loop, syempre, ayaw pag KVL sa current source. Same with this one, mag-apply man ka og KCL sa node, ayaw pag KCL sa naay voltage source. Okay? Take note, KCL needs current. But for voltage source, you don't have a current source. You don't have current for a voltage source. So, same ra gyapon to gibuhat gani ha, mapugos ka nga mag-add og additional unknown. So, mag-add ka additional unknown, you will just add additional equation. Okay? So, with that, as much as possible, lihayin ang pag-apply og KCL sa node nga walay voltage source. But take note, what are the rules in applying KCL? Okay, so take note rules. So, these are the rules in applying KCL. So, for example, if this is my resistor, and then connected siya sa lain nga resistor. Okay, for example, gani, sample lang ha. So, what if this resistor has current IA? Nya kanisad, this has current IB. Ayan. Apay, this is current IB, and this is also current IC. Now, the rules when you apply KCL, okay, current entering a node, okay, entering a node, that would be assigned as positive. And current, okay, current leaving a node, that would be assigned as negative. Okay, so for example, for this one, recall node is any point of 2 or more connections. Sa Bisaya pa sinumpayan. From this circuit, of course, mo ni ito ang sinumpayan. Yeah, mo na tong blue. Mo ni sinumpayan na ito diri nga pita. Okay, so let's call this node X. So if you're going to apply KCL at node X, okay, therefore again, no, we're going to use this one, and current entering a node is positive and current leaving a node is negative. Our IA is about to enter node X. So basically, IA is a current entering a node. So that will be positive. So we'll have positive IA. And then for IB, this is basically your IB leaving node X. So that is current leaving a node. So it will be negative. So minus IB. Okay? And then lastly, IC is also leaving node X. So if it is leaving, of course, it is negative. So negative IC. Okay? Since wala na may laing current na nag-involve sa node X or connected sa node X, then equate to 0. The same with KVL. Always equate to 0. So with this, okay, now tungod aning rules, diha na porma ang other definition nga current entering a node is equal to the current leaving a node. Because if you're going to rearrange this, you can form IA is equal to IB plus IC. Diba technically IA is the entering side and IB and IC is the leaving side. So this is where the other definition comes from tungod sa rules. Okay? The summation of current entering a node is equal to the summation of current leaving a node. Okay? So kanimo oy hinungdan. Nganong naporma ang lain nga definition, lain nga version sa definition. Okay? So this is your step number 4. Of course, when you are in step number 4 na, always good na. Always you can achieve the required number of equations needed. Always good na. Okay? It never fails. So, with this step, na-achieve na nimo ang desired number of equations, of course, you will proceed with step number 5. Okay? Diha, arita sa kilid na po. Okay, step number 5. For step number 5, you're now going to solve. Okay? Solve the unknown currents. So, this is the time nga makuha na nimo sa answer. Okay, solve the unknown currents. Okay? Ito na lang ni ibutang sa ubos B. Mabuo na malang jud kayo ni. Pusdan man mabuo na jud kayo ni. Sumpay na lang ni sa ubos. Hindi na tayo magdaskas pa og area. Technically, naman yun tayo makasag area, no? Kaya dako mo kani siya. Kung ako nang zoom out og maayo, ano ni kadako ang space. Na kung gisuwatan diri nga part. Okay. So, balik ta. Okay. So these are the steps, no? Basically, 5 steps lang. Okay? So sa 5 steps, assign current, assign loop, apply KVL, apply KCL, then solve. Assign, apply, solve. Okay? And ana na gid ang steps. Assign, apply, solve. Okay? Sige. There's nothing much better, no? Other than applying the steps into a circuit. So, let's have an example. Okay? There we go. Okay, example 1. So, let's start first with a very basic circuit. Okay? Okay. Medyo hiwi man. Meron mo kagamay. Ay! Nawa! Nice. The next page na di ay akin. Okay, meron mo ito na gamay. Okay, mga na. Then, erase. Okay. Then this one also. Then, okay, then this will be resistor. So, let's call this, let's not call it. Let's assign. Let's say this is 10 ohms. Then, let's say this is 20 ohms. And sad, let's say this is 30 ohms. Okay? And then, let's have this as a voltage source. Okay, let's say this is 220 volts. then another voltage source. Wait, the voltage source, okay, let's say 110 volts. Okay? So may pangutana na eh. Sige. Solve for the current. Okay, solve for the current flowing in every resistor. No? Solve for the current flowing in every resistor. Okay, sige, let's apply the steps. Okay, first, step number 1, recall, step number 1, assign current in every resistor or load. Okay, assign current. So again, when assigning current, the direction is up to you, left or right, up or down. Okay, and the name is up to you gihapon. Sige na for this one, let's call this, going to the right lang, let's call this I1. Okay, nya kani, sige, let's assume going down sa let's say I2. And then dere, para malahi, padong ni sa left. So let's call this I3. Ana, wala na may laing resistor, therefore, these are all the unknown currents. So take note, remember there's a note that the number of unknown currents equals the number of equations needed. So for this one, we have 3 unknown currents, therefore we need 3 equations. Okay? So dapat maka-achieve ta og 3 equations so that we can solve I1, I2, and I3. Of course, no? We have 3 unknowns go, therefore we need 3 equations. Okay? So step 1 is finished. Next, step number 2. Step number 2, okay? Step number 2, assign loop in every closed circuit where there are no current sources. So assign loop in a closed circuit. So recall now for this one, this can be a closed circuit. This can also be a closed circuit. Okay? And you can also have this also as a closed circuit. Kana. Okay? Pero, no, I'll give you a tip. As much as possible, kaning dako kayong loop, usually this is called the super loop because it has bypassed certain connections. So this is called a super loop. As much as possible, refrain from using a super loop. Okay, as much as possible. Why? It's because usually man good ang mahitabo basta mag super loop ka o kanang kanang simple lang nga loop niya, you're going to have it together with a super loop. Usually your equation will cancel out each other. So mahitabo mahimo imong equation mahimong 0 equals 0. Okay? So mo na ang usual nga mahitabo. So that's why as much as possible do not apply super loop as much as possible. Simple lang nga loop ang imuhang i-apply. So for this one, okay, so mag-apply ko og loop kanilang sa nga closed circuit og kani. Ayaw lang pag super loop yun as much as possible. Sige na, again, as I've said also, for the loop, it's either clockwise or counterclockwise. It's up to you. Okay? No matter what direction you assume ay kabalaka, di ka masakitan. Kaya dili na maka-affect sa final answer. Sige, now for this one, let's say, let's have this as clockwise. Okay? Loop A. Okay? This one, sige, clockwise lang gihapon. Loop B. Okay? So we now have our step number 2 finished. So yun na kasimple. Step number 1, assign current. Step number 2, assign loop. Na lang kasimple ang step number 1 o step number 2. But they are very critical. Why? Because if you have for example, naa kay nalimtan nga resistance og assign og current. Obviously, kung naa kay nalimtan, automatic wrong na imong mahimong equation. Okay? So dapat tanan gyud nga resistor ma-applyan nimo og current. Okay? And then as much as possible take note no nga mag-assign jud ka og loop in every closed circuit, but take note also nga it should be no current sources. For this one, since voltage source man ni puros, it's okay that we can assign loop. Basta take note that you have to assign loop in every closed circuit where there is no current source, just like this one, no? So I did not assign a loop just on this side but also on this closed circuit, okay, because this is a voltage source. Why? What's the effect of that? The effect of that would be you will have too few options of making an equation. Okay, as much as possible, you have to maximize your options of making an equation as much as possible para mas dali nimo ma-solve mo ang problem. Okay, so this is, we're finished now with step number 2. Okay, step number 3. Step number 3, apply KVL on the assigned loops. So recall the rules. For every assigned loop, you have loop A and loop B. Sige, first, KVL. KVL at loop A. Wait, okay. KVL at loop A. So recall the rules. First, let's start with the tail ends ato ang loop. Ang tail end diagi first, okay, sa voltage source. So the tail end started entering the negative side but exits the positive side. So recall, you should follow the exit sign. So for this one, okay, when the loop flows through the 220 volt resistor, it has exited on the positive side. So therefore, you will have 220 positive. Okay, then your loop, okay, then your loop goes through the 10 ohm resistor. So you should take out the voltage again. When you apply KVL on the loop, all voltages being run through by the loop or being passed through the loop, you should get the equivalent voltage. Okay, so tanang maagian sa loop, dapat makuha nimo ang voltage, but this time your loop has passed through the 10 ohm resistor. On that moment, your loop A is going to the right ang direction. But take note, I1 is also going to the right ang direction the moment loop A flowed through the 10 ohm resistor. So as you can see here, the loop A has the same direction with loop I1, not loop I1, current I1. And based on the rules, if the loop and the current is the same in direction, the voltage would be negative. So for this one, you will have negative I1 times 10, or ako lang buhaton 10 I1. Okay? So I times R. Okay, we're now finished with the 10 ohm resistor. Now, your loop goes through the 20 ohm resistor. So we have to get the voltage on this resistor. But upon passing through the 20 ohm resistor, the direction of loop A is going down. While also I2, the direction is also going down. So same direction. Therefore, the same direction, recall the voltage is negative. So you will have minus 20 I2. Okay? Then your loop goes back to the first, to the starting point. Therefore, wala na kay laing magian. Okay? Sila ramang tulo. Then equate to 0. Okay? Again, KVL and KCL should always be equal to 0. Summation equal to 0. Sige, let's call this our equation number 1. Okay, so we now have one equation. Okay, so 2 equations na lang because we need 3 equations man. Since we already have 1 equation, we only need 2 equations na lang. So since we're finished with loop A, we will proceed with KVL at loop B. Okay, so at loop B, what are we going to do with loop B? For loop B, you will have, again, starting with the tail part. So loop B flows through the 20 ohm resistor. So on that moment, when loop B flows through the 20 ohm resistor, its direction is going upward. But the current on the 20 ohm resistor, which is I2, is flowing downward. Okay? Their directions are opposite. Recall the rules. Basta opposite ang direction. Okay? Sa loop and the current, the voltage will be positive. So for this one, this will be positive 20 I2. I don't need to write positive there, ha? Okay? So, sabot na nga positive na siya. Okay? So, we're now finished with 20 ohms. Then, the loop goes through the 30 ohm resistor. The moment loop B flows through the 30 ohm resistor, its direction is going to the right. Okay? But I3's direction is going to the left. Again, opposite ang direction. So, this will be positive. So, plus 30 I3. Okay? Then proceed. Then the loop flows through the 110 volt source. It enters the positive side and exits the negative side. So again, you follow the exit point. This will be negative 110. Okay? Then it goes back to the starting point. So therefore, you will equate this to 0. So you now have your second equation. Okay. So since we need 3 equations, 1 equation na lang. So, asa man tag ika-third equation, sir? Okay? Mag-super loop ta, sir. Now again, as much as possible, do not apply super loop yet. Okay? Now, asa man tag third equation, sir? Now recall, we're not out of options yet. As I've said before, if on the step 3, you still haven't achieved your required number of equations, you can proceed with step 4, which is to apply KCL. Okay? Apply KCL to any node. Now, all we have to do right now is determine how many nodes are there in this circuit. Okay? Now, sige daw. Let me ask you a question. How many nodes are there in this circuit? Bidaw, palihog na kung pila ka nodes or sa Bisaya pa pila ka buok sinumpayan ang circuit na to diha be. Sige daw. Pila ka buok sinumpayan?
Upat, sir. 4.
Ha?
Four, sir.
4. Walay 1, walay 2 diha.
2, sir.
Naay 2.
Doa, sir, doa.
Unsa man na para lang na ay kuan other option? Okay, no, sige. Answer is, in this circuit, there are 4 nodes. Yay! Sakto ang 4. So, anong 4 man, sir? Okay? So, recall ha, node. Again, sa Bisaya pa sinumpayan. So, let's determine asa may mga sinumpayan diha. So, let's start with the obvious ones, of course. Kani. Okay? Kani, kani. Diba, sinumpayan na. Or node na for the 10 ohm, 30 ohms, and 20 ohms. Sinumpayan na nilang tulo. Of course, let's call this node, node, kung AB ni, node 1 na lang, node 1. Okay, node 1. The other obvious node is, adi ko sa ubos. Ako lang padakon. Okay? Pwede naman sa pagamyo, no? Let's say, diri lang dapita. Pero padakon na nako para maklaro, yun, kinsay mga connected ani nga node. Okay? Now, this node is a connection of the 20 ohm, the 110 volts, and the 220 volts. Okay? So, this is another node. So, let's say node 2. Okay? Asa man na ikatulong ikaupat, sir? Of course, ang connection between the 220 volts and the 10 ohm resistor. Okay? Siyempre, naagin na sila sinumpayan, dili pwede guha. Okay? So, let's assume na lang, kanila lang dapita, iyahang sinumpayan. Pwede rin bisag asa, let's say, dari part, dari bakhang part. Okay? Para mas distinct lang ato ang location, dili lang ako ibutang. So, let's call this as our node 3. Okay? And of course, kung naanay sinumpayan silang duha, syempre sila nasad sila sinumpayan. So, recall holding hands while walking. So, nagsumpay lahang mga kamot. So, let's call this node 4. Okay, so you have 4 nodes in all. Okay? So, inanahan, when you look for nodes, you have to take note nga, it's not just kanang daghan o connected diha. Mo na node. No. Even if duha lang kabuo connected, it's also considered as a node. Okay? May connection diha. So, it's also considered as a node. So, for step number 4, we're going to apply KCL to any node where there is no connected voltage source. Dapat walay connected nga voltage source. Node 1, okay, walay connected nga voltage source. They are all resistors. Node 2, no, not good because there are 2 voltage sources connected. Samot na si node 3 o si node 4. Okay? In every node, there is a voltage source. Sa node 3, si 220 volts. Sa node 4, si 110 volts. Okay? Therefore, only one node ra ang pwede applyan og KCL. But we don't have to worry about that because we only need one equation na lang. Okay? So, muna akong giingon, as long as you perform step 3 and step 4, you will achieve your desired number of equations good. It will not happen nga dili. Okay? So for this one, we can apply KCL. Rin na. Black lang. KCL at node 1. Ay, by the way, naagya po yung scenarios no nga, even if nag-KVL and KCL na ka, you still did not achieve your number of equations. Okay? So muna na yung time na mag-super loop ka. Pero those circuits are rare. Okay, panagsara na siya nga mga circuits mahitabo. O kung naamang gani na nga circuit, you don't have to worry. You can apply another method. Okay? Kay mas hassle man kumpara sa mag-apply ka og other method. So meaning, aside from Kirchhoffs law, there is other method also that you can apply in a network circuit. Okay? Sige, for this one, balik tayo sa KCL at node 1. So again, entering current is positive, leaving current is negative. So from here, I1 is about to enter node 1, so that would be positive. I2 is leaving node 1, so palayo na siya gikan ni node 1, so negative, minus I2. And lastly, I3 is going towards node 1, so positive. So that would be plus I3. Okay? Then there are no other unknown currents connected sa node 1, then equate to 0. So now we have our third equation. Okay? So we have achieved our desired number of equations. Then step 5 na din, solve the unknown currents, which is, okay, coincidentally, that is what we're looking for. Solve for the current flowing in every resistor. The current flowing in every resistor is I1, I2, and I3. Okay, so let's solve. So for this one, algebra na lang ta. So recall mo sa inyong algebra. Okay, how to solve this one? It's either you can use substitution method or elimination method. Okay, for me, I will use substitution method. Okay, I will transform equation 1 into I1 in terms of I2. So, i-transfer na ko aning 10 I1 sa PCAS, mahimo ng positive 10 I1. Nya, tanggalon na ko ang 10, may bilin I1 na lang. So, that would be I1 is equal to 220 minus 20 I2 divided by 10. Okay? So, recall ha. Subaya lang ninyo, mga engineer man mo. Engineering day. Okay, so ibalhin ni dere, then i-divide ang 10 para I1 na lang mahibilin. So let's call this equation 1 prime. Okay, then ako sa equation 2, ako sa ibalhin si, positive naman kanina lang akong ibalhin. Ibalhin ako sa pika si I2, 20 I2 o si 110. Then i-divide na ko by 30 ni para mabilin I3. So I can have I3 is equal to, negative 110 becomes positive. Then 20 I2 becomes negative, minus 20 I2 divided by this time 30. Let's call this equation 2 prime. Okay? Then my equation 1 prime and 2 prime, I will substitute it here in my equation 3. So 1 prime and 2 prime in equation 3. So you will have first for I1, this is 220 minus 20 I2 divided by 10. Okay. Then minus I2. Minus I2. Wala man kay kuan rin, no? I2 na rin. So I2 alone. Then plus I3. I3, you have here your I3. So 110 minus 20 I2 divided by 30. Then equate to 0. Okay. So for this one, you only have one unknown. Okay, basta usa na lang gani ka anon, musugot ra ko nga diretsoon og calculator, shift solve lang. Pero inani gani nga 3 equations, 3 unknowns, dili ko musugot ha nga inyo ra pud nang diretsoon og calcio by using the calculator, masolve ani sa calculator. Nabiya tay 3 equations, 3 unknowns sa calculator, okay? Now, inani gani di ko musugot ha nga diretsoon og calculator, okay? You have to solve manually. I will only allow direct solution through calculator if isa na lang ka unknown. If you only have one unknown left, okay? Sugot ra ko ana, basta usa lang. Pero kung multiple pa gani, you have to solve it manually. Okay? Sige, no? So, ato nang sulbon. Okay. You have to, fraction to 20 minus 20 alpha x divided by 10. Then, minus alpha x. Okay, then plus 110 minus 20 alpha x divided by 30. Then equate to 0. Okay, then shift solve. False. Aba, answer na yun. Okay? Mas ninot mo muna sa actual calculator. Tapos na yung answer. So therefore, I2 is equal to 7 amperes. So we now have I2. Therefore, we can now solve for I1 and I3. So this will be 220 minus 20 times 7 divided by 10. Okay? So that is the 20 minus 140 that is 80 divided by 10, 8 amperes. Okay? Then for I3, this will be 110 minus 20 times 7 divided by 30. So 110 minus 40 minus 140, negative 30 over 30. This will be negative 1 ampere. Okay? Uy, sir, negative lagi na, sir. Now, kanino? Don't worry, kanang negative. Rito sa green. Okay, kanang negative only denotes, okay? Only denotes wrong, okay? Wrong assumption of direction. Okay, wrong assumption of direction. Meaning, ang kanida ang I3 mo no? Ang kanida ang I3, ang actual gidayan niya nga current should be not going to the left, but ang actual niya nga direction should be going to the right di ay. Sir, ingon ka sir, di may masakitan kung mag-assume mi ani nga skuan, circuits. Okay? Now don't worry, di mo ka masakitan nga naman. Even if negative na siya, but the numerical value kanang 1, sakto ra gihapon na. If ever manggana no, for example, if at the start ang imuhang I3 is na-assign nimo going to the right, okay? Okay, kung at the start mo lang daan going to the right na siya, pag solve nimo diri imuhang answer sa I3 will be positive 1. So meaning, same ra gyapon ang answer, mulahi lang negative na alay nakabutang ang negative. Okay, so you don't have to worry about the negative. Ang value niya, numerical value, sakto ra na. Okay? So that is how to use Kirchhoffs law on a circuit. Okay? So far, any questions regarding Kirchhoffs law? Mga pangutana sa application sa Kirchhoffs law.
What if ang iyang assumption, sir, kay sakto, sir? Negative gyapon to mula ba, sir?
Amo to kung gingon ganiya nga what if sa start pa lang daan ang imuhang I3 is going to the right na. So ang resulta na diri imuhang answer positive na, wala na nang negative. So positive 1 na siya. So muna kung gingon nga if ever manggani na sayop ka og assume sa direction, you don't have to worry because negative ra ang mugawas ana pero ang value same ra gyud. Mo ra gyapon ang answer. Okay? So in short, pwede ra ka mo hatag og negative nga answer. Kay kuan ra man na, wala ra may difference sa iyang numerical value. Okay?
Sa sign ko, sir, pwede ba mailis-ilis, sir?
Ha?
Ang sign, sir, pwede ba magka-sayop, sir?
Pwede ra. So pwede ra ang sakto gid nga answer positive niya imong nabutang kay negative pwede ra. Okay, wa kay problema na kay sa pasabot ana bali ang direction. Ora man ay ilahanan. Actually no, inig actual ana kung mag-measure ka, inig actual na mag-measure ka sa tester, kung bali imuhang pagkabutang sa imuhang test pins, ang mugawa sa imuhang tester negative pud ang value. Pero kung imo nang balihon, same ra og value pero ni positive lang. So muna nga di ka ngay mabalaka kay kanang value maura gid gihapon na bisag bali-balihon pa na nimo. Mausab lang kay mahimo lang positive or mahimo lang negative. Okay? Any other questions regarding Kirchhoffs law? Tara. Okay, no? So again, mas maayo gid na nga naapay laing example. Okay, labi na kani siya nga part no, puro man ni voltage source walay current source. Sige, mag-add ta og example nga naay voltage source na apoy current source. Sige, let's have example 2. Okay, naning green. Black ni hapon. Okay, example number 2. Example number 2, let's say, saan nga sample may hatag? Siguro. Okay. Okay, kani, and then, Diri siguro, tanong nato diri og mga resistor, and diri kay mga sources. So let's say, current na resistor ni, let's say 6 ohms. Yung kani, let's say 4 ohms. And then here, let's say this is 8 ohms. And then dere, let's assume voltage source ni, butang tag 110 volts ni. Yeah, dere, assume na itong current source ni. Okay? Para natay example na current source. So let's say 5 amperes ni. Okay. Sa may pangutana. Sige. Let's say you have here current I. And ang question is solve for I. Ana, muna yung question. I-solve ning current I. Okay. Sige, no? Again, let's apply using the Kirchhoffs Law. Step number 1. Again, step number 1, assign current in every resistor. Now, sir, na may current si 4 ohm resistor. Oh, you don't have to worry about that na. Naman siya naka-assign nga current. Di, ayaw, nagbutang iglain. Muna na siya. Okay? So, rin na lang pikas. Let's say, this one, going down lang. Let's for example. So, butang tag current IX lang ni. Kani, sige, padung na ni babaw. Okay, let's say current IY. Okay? So, mana. We now have 3 unknown currents, Ix, Iy, ug I. So therefore, we need 3 equations gihapon. Okay, so finish with step number 1. Step number 2. Step number 2, assign loop to a closed circuit wherein there is no current source. So technically, in this circuit, we can form 3 simple loops. Kani, closed circuit man eh. This is also another closed circuit, and this is also another closed circuit. But take note nga, assign lang ta og loop sa circuit, sa closed circuit, where there is no current source. So we cannot apply loop here. We can only apply here. Ato lang usbo ng color para mas maklaro. Okay? So this is loop. Unsa naman sad ni? Loop A lang gyapon, loop A. And then here, sige, balihon ako. Ano lang, counterclockwise. So let's call this loop B. So I cannot assign a loop here because there is a current source. Okay? So, finished with step number 2. Now, let's proceed with step number 3. Step number 3, apply KVL to the loop. Okay, so for this one, first, KVL at loop A. So for this one, KVL at loop A, you will have, starting with the tail, it entered the negative side sa voltage source and exit sa positive side. So again, you follow the exit side. You will have positive 110. And then, the loop flows through the 6 ohm resistor. And that moment, nga ni-flow ang loop A sa 6 ohm resistor, its direction is going down. And also, Ix is also going down ang iyahang direction. So therefore, negative ang iyahang voltage. So negative 6 Ix. Okay? Then, ibalik naman sa starting point. Wala na ilaing giagian sila ram duha. So again, you can equate it to 0. Okay, for this one, we can solve directly Ix. So this will be Ix is equal to, transfer ko na sa pikas, this will be 110 over 6. Oh, much better, no? Nanatay value ni Ix. Okay? Much better. Next, you have KVL ta ni loop B. Okay? KVL. Okay? Pari na lang ko ba? KVL at loop B. Okay, so at loop B, sige, starting with the tail side. Okay, at the tail side, it flows through the 8 ohm resistor. So when it flows through the 8 ohm, when it passes through the 8 ohm resistor, on that moment, loop B has a direction going up. And also, IY has a direction of going up. So recall, if both directions are the same, voltage will be negative. So this will be negative 8 IY. Okay? Next, you will have current, loop B flows through or passes through the 4 ohm resistor. Wherein on that moment, when loop B passes through the 4 ohm resistor, on that moment, loop B has a direction of going to the left. But current I is going to the right. So opposing ang ilahang direction. If their direction is opposing, recall, voltage will be positive. So this will be plus 4I. Okay? Then lastly, kay mo naman lang nila ang resistor, may lain, loop B flows or passes through the 6 ohm resistor. So when it passes through the 6 ohm resistor, loop B, on that moment, its direction is going downwards. And also, IX is also going downwards po. So again, same silang direction, no? So same direction, voltage will be negative. Negative 6 IX. Okay? Then after that, wala na ilaing giagian. Okay? So equate to 0. But take note, we have already solved for IX. So we can substitute this. IX is 110 over 6. So we will have negative 8 IY, okay, plus 4I. Then this time, cancel ang 6. We will be left with minus 110 is equal to 0. Okay. So let's call this our equation number 1. Ha? So, technically speaking, no? Technically speaking, this is our equation 1 and this will be our equation 2 na. Okay? So, ano na lang, no? Para ma-follow gihapon tong pila ka number of unknowns will also be the number of equations needed. So, we now have our equation number 2. Okay? So, we only need one equation more because we have 3 unknown currents. Therefore, we need one more equation na lang. But there's no more loop. So therefore, again, proceed to step number 4. Step number 4, apply KCL to any node. Okay? Where there are no voltage sources connected. Now, for this circuit, technically, we have 3 nodes. Okay? Node over here. Okay? So wherein this is the connection between 110, the 6 ohms, and the 4 ohms. Node over here. Okay, this is the connection between the 4 ohms, the 8 ohms, and the 5 ampere current source. And lastly, the one below, no? Node below, this will be the connection between the 110 volts, the 6 ohms, the 8 ohms, and the 5 ampere. Okay, so this is where they converge or they connect one another. So again, apply KCL to a node where there is no voltage source connected. So we cannot apply KCL here because there's a voltage source. Similarly, on this one below, because there's a voltage source connected. So the only remaining node that we can apply KCL is this one. And fortunately, we only need one more equation na lang. So let's call this node 1 lang gihapon, node 1. Then applying KCL at node 1. So recall, KCL, entering current is positive, leaving current is negative. So 5 amperes, it started 5 amperes, it's entering node I, node 1, so that would be positive. Okay? Then ang IY is also about to enter node 1, positive gyapon, plus IY. Then current I is about to enter gyapon node 1, so positive gyapon, so plus I is equal to 0. Okay? So this will be our third equation. So again, we now have 3 equations, 3 unknowns. So this time, we can proceed with step number 5, solve for the unknown currents. Now, since the example only needs current I, no need to solve for IY. Okay? Hindi na natin mabablema, ana, kay ang ato raman importante is ang current I raman. So we need to we need to perform algebra on the equations such that we are left with only current I. So for that, I will arrange equation 3 into IY is equal to, ipamalhin ko ni speakers kaning 5 og I. So negative 5 minus I, let's call this equation 3 prime. And then kaning equation 3 prime, I will substitute it here sa ako equation 2. So 3 prime in equation 2, you will have negative 8 IY. So that is negative 5 minus I plus 4I. minus 110 is equal to 0. So again, as long as isa na lang ka-unknown, masagot ra kog diretso unog shift solve. So with that, okay, you will have negative 8 times negative 5 minus alpha x, then plus 4 alpha x, then minus 110, then equals 0. Shift, wait, equals 0. Dala mo ng 0. So shift solve equals. What's the answer? I is equal to 5 point, ito po mga decimal. Decimal ba na yung 5.8333 amperes. Okay? So you now have your current I. Okay? So far, any questions? For example, number 2. Mga pangutana sa example number 2. Okay, no? So, as you can see here, as long as you just follow the steps, you can easily, okay? Again, ang word easily. So, dili na to gamiton ang word nga easily. So, ikaw na lang, you won't have a hard time applying Kirchhoffs law on a circuit if you just follow the guide. Okay? If you just follow the steps. So, again, kanina mga steps dire, basta sundon lang yun mo, you won't have a hard time. Except lang kung if you can form your own steps, then much better. Again, pasabot ana, you have a deeper understanding of the Kirchhoffs law. Okay? Now, sige, let's end it here, no? Kaya nanakit na ang tutunan. Okay, nilapas na sa 60%. Okay, let's end it here. Now, pwede pa ba? Ako na lang unta ning lahuso, no? Sige, lahuso na lang ta ni. Sample number 3 ta. Ha. Example number 3, anong mga example number 3 pa man ko? It's because so far sa example 1 and 2, walay dependent source. Puro independent sources. Okay? So let's also have an example where there is a dependent source. So, sige, no? Maghatag tag example nga na ay dependent source. Okay. So I have the right circuit for that one. Okay, nag-involve og dependent source. Okay, then erase ni. This one and this one. Yeah, this one pa good. Okay. This will be a resistor. 3 ohms. This will be a resistor. 6 ohms. This another resistor. 2 ohms. And this is a current source. Okay, so 5 amperes. Then this is a dependent source. Now, dependent na current source. And its value is V over 2. So meaning this is a voltage controlled current source. Now, asa man gikan ang V? Okay? So the V will be coming from here. V will be the voltage in your 3 ohm resistor. So whatever is the voltage in your 3 ohm resistor divided by 2, that will be your value of your current source. Okay? So again, no? Again, we now have a circuit wherein there is a dependent and independent source. Now, sir, what are we going to do here? Can we still apply the steps? Answer is yes. So even if dependent source na siya or independent source na siya, you can still apply the same steps to that circuit. Okay, we have 30 minutes. Tarapod. Okay? So, again, apply the steps. Step number 1. Step number 1, assign current in every resistor. Sige. For 2 ohms, sige, going down lang ni. Let's say I2 lang ni. Nyaka ni, sige, going to the right lang ni. Let's call it I6. Nyaka ni 3 ohm resistor. Now, by the way, no? Okay, naam ni siya sign plus minus. Na take note, okay, take note, akong isuot na rin. Don't worry no, kani siya kung ang ipanghimo, ako rin yung isave into PDF, then i-upload na ko sa tuwang channel. Take note, current, okay, current moves from positive to negative. Maunay movement sa current. Now, since we are already given with positive, negative here, okay, we already know nga ang current direction ani should be downwards. Okay? Wala gyulain. Di ka pwede mag-assign og upwards. Kaya kung mag-assign kag upwards, we already know nga ang value ana negative na. Okay? So mag-assign na lang tag downwards so that ang value is positive. So let's call this I3. Ana. So we now have three unknown three unknown currents. Therefore, we need three equations. Okay? Now, that is step number 1. Step number 2. Again, step number 2. Assign loop to a closed circuit where there is no current source. So in actual, this circuit, you can form three closed circuit. So this is a closed circuit. This is another closed circuit. Okay? And this is another closed circuit. But then again, you cannot assign loop where there is a current source. So di pwede dere. Di sad pwede dere samot. So therefore, dere na pwede. Sige, no? Aha. Let's assign here a loop. As usual, loop A lang gyapon, no? So we now have step number 2. Okay? Excuse me. Now, proceed on to step number 3. Step number 3, apply KVL to the loop. So KVL, okay, KVL at loop A. So KVL at loop A. So again, starting with the tail part. So loop A follows or passes through the 3 ohm resistor, and that moment, loop A has a upward direction, while I3 has a downwards direction. So opposite ang ilang direction, therefore voltage here will be positive. So that would be 3I3. Okay? Then loop A passes through the 6 ohm resistor. On that moment, loop A has a direction going to the right. And I6 is also going to the right. So that would be negative. So minus 6I6. And lastly, loop A passes through 2 ohm resistor. Okay, on that moment, loop A has a downward direction. And I2 also has a downward direction. Therefore, same direction, that would be negative. Minus 2I2. Okay, goes back to the starting point. Therefore, equate to 0. You will have your equation number 1. Okay? Next. Uy, wala namang ko'y laing loop. So we will proceed with step number 4. No? Mag-apply tawag KCL. So question is, how many nodes are there in this circuit? Now for this circuit, actually, you can have 3 nodes for this one. Asa man, sir? Okay? First node. This one. Kani, dagandaghan yun siya og connection. Kani, no? Okay, this is a node wherein it represents the connection between this dependent current source, the 6 ohm resistor, the 3 ohm resistor, and the 5 ampere current source. Now, some of you, I believe, was thinking, pwede bungkagon. So, kani nga connection o kani nga connection. Okay? But technically, connected naman gina silang duha, no? Now, why can I say nga, some of you are thinking nga, duha na sila ka different nodes? Because I've experienced that before from my previous students, okay? For the past 10 years. Naagi students nga, ang ilang thinking ani is, duha ni ka node. Kani nga node o kani nga node. Pero take note, connected man gihapon na, so it can be as one. So if it can be connected as one, then don't divide them. Okay? Marong, ang tendency ni mo ana, marong na may equation noon. So, connect it as one. As long as they are connected, then that is one node. Okay? So, let's call this node 1 gihapon. Saro. Okay? Then, this other one. Okay? So, let's call this node 2. And of course, lastly, there is a bus. Okay? Ang connection between nilang tulo. So, let's call this node 3. Okay? Now, since we need 2 more equations because we have 3 unknown currents, therefore we need 3 equations. So we have to apply KCL 2 times. So first, Recall you can only apply KCL to a node where there is no voltage source. But fortunately on this circuit, there are no voltage sources, only current sources. So we can apply KCL at any node here. Okay? So depende na na mo. Sige, for me, sige, I will start with KCL at node 1. Yeah, ako mag-start. Okay? So again, current entering is positive, current leaving is negative. Starting with 5 amperes, it's entering node 1, that would be positive. Okay, I3, it's leaving node 1, negative. Okay, and then, ang connected ra sa node ha, mo imuhang apply KCL. Next is ang I6, okay, it's leaving node 1, so minus I6. And lastly, kani siyang V over 2, it's entering node 1, so that would be positive. Okay, positive V over 2. Okay, sir, how about ang I2? Take note, I2 is not connected to node 1, so you will not include that one. Okay, so I've said that because previously, I've also met students nga, gi-appeal yun ng current. Okay, bisan pag it's not connected to that node. Okay, so no ha, only those that are connected to the node. So for this one, there are no more other connections, therefore equate to 0. So this will be your equation 2. Okay, then we need one more. Sige, mag-KCL lang ko sa node 2. Okay? Sir, pwede na sa node 3? Yes, pwede na sad, no? So again, you can apply KCL at any node here because there are no voltage sources. Everything is a current source. Sige, apply KCL at node 2. Let's start with sa node 2, V over 2. It's leaving node 2. So that would be negative V over 2. Then, I6, it's about to enter node 2, so positive I6. And lastly, you have I2. It's leaving node 2, so minus I2. Since there are no more connections, equate to 0. So this will be your third equation. Okay? So now we have achieved the 3 equations. So let's proceed with step number 5. Step number 5, solve the unknown. But there is a but. If you have observed properly, we have 3 equations. But looking at it closely, we don't only have 3 unknowns, but 4 unknowns. Ilang 4 na unknowns, sir? Aside sa I3, I6, of I2, we also have the unknown V. Di ba? One time mo, uy, so kung inana na sir, 3 equations, 4 unknowns, di ay we cannot solve this. So may buhaton na to, sir. Now, there are plenty of ways to solve this. One of the ways, you can also apply KCL sa node 3. Of course, you need a 4th equation because there is a 4th unknown. So therefore, you need a 4th equation. So, pwede, you can apply KCL sa node 3. But, I advise you to not do that because your solution will become more complicated. Okay? It's so hard to simplify 4 equations, 4 unknowns. Okay? Kung dili man gani hard para ninyo, for me, hard. Okay? Dili gid sayo nang pag-simplify sa 4 equations, 4 unknowns. Okay? Instead, sir, kailangan magitag 4th equation, sir, because we have a 4th unknown. Okay? Now, instead, you focus on the unknown V. Diha ka mag-focus. Okay? Nga naman, sir, unsa may naa sa unknown nga V. Okay? Now, the unknown voltage V, take note, is located on the 3 ohm resistor. Okay? Naadari, no? Now, the 3 ohm resistor, of course, na ay voltage V, na ay current I3. Now, if you can recall, di ba, from Ohm's law, V is equal to I times R. Okay? May blue naman niya akong gamit. Blik. Black. Hindi na lang ito. So, it should be V is equal to I times R. Diba? Mamana from variation sa Ohm's law nga I equals V over R. Now, technically, ato ang V dere na kay current I3. You also have resistance which is 3 ohms. Therefore, your V can be equivalent to 3 I3. Okay? Or if I'm going to rearrange this one, I will make this as I3 equal to V over 3. In such a way, so I've rearranged it this way so that I can substitute I3 here. Okay? Ay, by the way, also na question, ano, sir? By the way, ang question ani is solve for V. Mo the question ani. Nalimot mo nang kubutang question ni noon. Okay? Ang question ani is solve for V. Kani may pangitaon kana. Shh. Saan kung ito ni galing noon? Okay, solve for V. Now, since V man mo'y pangitaon, I will eliminate I3 by substituting I3 with V. So muna, ginani na ako such that I can substitute it here. So with that, pwede na ako niya ma-substitute. This will be V over 3. So with that, so may laing I3. Dapat yun. This will be V over 3. Okay. So with that, no? This will become, okay? This will become 3 times V over 3. Makancel ang 3. V na lang. V minus 6I6 minus 2I2 equals 0. Equation 1 prime. Then this one, 5 minus V over 3 minus I6 plus V over 2 equals 0. Equation 2 prime. Okay? Okay. So, this time, legit na nga, 3 equations, 3 unknowns. So, our only unknowns na lang is I2, I6 of V. So, wala na ning I3. Okay? So, this time, pwede na tayo mag-substitution or elimination. Sige, unsa na akong buhaton? Aha. How about I will change this equation into, i-transfer na kong I6. This will become I6 is equal to 5 minus, balhin ko ni Spikas, 5 minus V over 3 plus V over 2. So let's call this equation 2 double prime. Then, i-substitute na ako dire. 2 double prime. Yan na lang, mayari na lang. 2 double prime in equation 1 prime. Okay, substitute na ako dire. This will be V minus 6 times 5 minus V over 3 plus V over 2 minus 2I2 equals 0. Or if I'm going to rearrange this one, I can have this, balinas pikas, can have I2 equals V minus 6 times 5 minus V over 3 plus V over 2 divided by 2. Okay? So we now have I2 in terms of V. We now have I6 in terms of V. Then, substitute it here. Okay? I2 and I6. Okay? In equation 3. Aha, nanawag na ako. Unya na na. Okay? Yan na. Padayon na yung klase. Kahapit na ang time. Okay? So, I2 and I6 in 3. So, ang I2 na to you have here, this one, no? V. So, first, you have negative V over 2. Then, plus, ang I6 na to is this one. So, recall 5 minus V over 3. So, this will be 5 minus V over 3 plus V over 2. Okay? And then, lastly, minus I2. So, I2, this one, that would be V minus 6 times 5. Lag again. Minus 6 times 5 minus V over 3 plus V over 2 divided by 2. Okay, then equate to 0. Okay, so as you can see here, only one unknown. Pag-calculate na lang na ito, ani. Saan mo ito kung calculate? Okay, so pag-calculate na lang, ani. So you have negative ni, negative. Negative alpha x over 2. Then plus, okay, 5 minus alpha x divided by 3. Okay, plus alpha x na sa divided by 2. Almost divided by 2. Then, minus fraction. Sa babaw, fraction pa yun. Pwede pa dahil. Alpha x pa. Minus 6 times 5 minus fraction dayon, alpha x over 3. Then plus alpha x over 2. Okay. Then divided by 2 equals 0. Shift solve. 60. Automatic. Gawas na yun. Okay. So for this one, V is equal to 60 volts. We now have our answer. Okay. So far, any questions sa example number 3? Medyo taas gid siya gid. Pero bisan pa og naa kay dependent source or naa kay independent source, ma-apply gyapon ang steps nga akong gihatag sa inyo ha. Okay? So any questions regarding example number 3? Wala na guys. Okay? So muna no? These are these are examples wherein okay, lain-lain nga example, lain-lain nga scenario, pero nasolve gihapon using the steps I've given you. Again, you are free to use the steps I've given you as a guide to solve the circuit using Kirchhoffs Law, or you can also make your own steps. Okay, you can also make your own procedure. As long as sa kuan ra gyapon no, ni-apply ra gyapon ang same nga rules. Okay, sa KVL o sa KCL. Okay, valid gihapon ang imuhang procedure, okay ra na siya. Okay? So, wala na gyud laing mga pangutana. No other questions? Okay, since there are no other questions, let me end this recording. No?